In this video, we will look at certain specific or special properties of real numbers. We have seen all the field axioms. Now, out of those axioms, what I feel you should know about certain special things is number one. Let me just write it down for you. Essentially, what I'm trying to say is that the neutral elements of addition. So we have seen certain addition properties. We have seen 5 addition and 5 multiplication properties of field, right? And the neutral element of, not elements, element of multiplication. Are actually unique. Now, what do we mean by neutral element? Now, neutral element for addition is 0, the identity of addition, and the property of it is that when you add it to any real number, it will give the real number itself. Okay, so let me just try to prove it. So first we'll do it for addition. Okay, let's do it for addition. So suppose we have, I'll do it by contradiction. So when we are doing it by contradiction, what we are doing is that we are nullifying what we want to prove. So by contradiction, what I mean is that I'm saying that it is unique, but let me just start off with what if when it is not unique. So let me have 2 neutral elements. Okay, so let us, if possible, take 2 neutral elements for addition. Okay, so let us just take 2 neutral elements for addition. Now what is happening if I have 2 neutral addition elements? So let us take it as 0 and 0 dash. So 0 and 0 pi are 2 neutral elements. Okay, then actually 0 is a neutral element. So let me first start with 0 neutral and 0 prime any real. Okay, of course it's a neutral element in the real numbers, so it is a real number also. So 0 prime will equal to 0 plus 0 prime, right? It will be equal to 0 plus 0 prime. Why? Because I'm taking 0 as neutral. In the same, if I take, let me just change the color, take 0 prime as neutral and 0 as real, then what will you get? 0 equals to 0 prime plus 0. Okay, so quote it as 1, 2. So essentially, if you notice, 1 equals to 2 because 0 plus 0 prime equals to 0 prime plus 0. Okay, so this will imply that 0 prime actually equals to 0. So you can only have one unique neutral element in the field. Okay, similarly for multiplication. So we'll do it for multiplication. Now for multiplication, suppose again I have 2 neutral elements. Suppose we have 2 neutral elements, 1 and 1 prime are 2 neutral elements in the field. Okay, in multiplication. or actually for multiplication in the field. Okay, so that would mean that 1 prime equals to 1 into 1 prime. Now here what we are doing, we are taking 1 as neutral and 1 prime as any number in the field as some number in R. Okay. Similarly, 1 equals to 1 prime into 1. Here what we are doing, we are taking 1 prime as neutral. Okay, and I am writing the wrong spelling, I guess. Neutral. Okay, and 1 as any element. So this means, again, let us put it as 1 and 2. You see the RHS of 1 equals to RHS of 2, which implies 1 prime equals to 1, and hence you can only have unique neutral elements. The unique neutral element for addition is noted as 0 and 1 for multiplication. So addition, it's 0, for multiplication it's 1. Okay, so that's the proof of it.